Thank you so much for joining us for our Eclipse education series that Ohio State Lima, in conjunction with Rhode State College, are putting forward for our community. So the Eclipse Science Series is brought to you through the generous support of Charles River Laboratories and includes 4 speakers discussing different aspects of the total solar eclipse that will occur on April 8th. So tonight's speaker, Dr. Wayne Schlingman, is the director of the Arnie Sledeback Planetarium at The Ohio State University, where he joined the Department of Astronomy in 2014. He received his PhD from the University of Arizona, where he worked with Ed Prather and the Center for Astronomy Education, researching the teaching and learning of general education introductory astronomy. He also collaborated with Yancey Shirley, studying star formation via dense gas tracers in the Milky Way galaxy. Dr. Schlingman then joined the University of Colorado Boulder, working with the general education, non-science major, like me, introductory astronomy classes, and the Fisk Planetarium. At Ohio State, he has been working with faculty and students across many departments to fully utilize the exciting technology available in our full dome theater, reaching thousands of students and members of the public, while championing the use of active engagement, learner-centered instructional strategies in public events to engage our public beyond just the simple consumption of information. Dr. Schlingman most recently won a 2023 Community Engaged Practitioner Award from our university's provost office. This evening, Dr. Schlingman is going to share his passion for astronomy as he discusses why eclipses continue to enthrall us. Thank you.
Yeah. All right. How is everybody? Good. Now that we've driven through the void, driving this morning, it was like driving through the void. And I guess I should probably just say a couple things about myself. While it sounds like I've done a lot, I have also made myself 4 promises that I would never do things. Never wanted to work with non-majors, never wanted to learn quantum mechanics beyond what the classes I took, but radio astronomy is quantum mechanics. Never wanted to study the solar system, and I never wanted to be an academic. So you can see how well saying never gets you here in the universe. But tonight we're going to be talking about this, our solar eclipses. So why do solar eclipses enthrall us all? Who has an idea? Why are eclipses so dang cool? I mean, there's the obvious one. It's space, and everybody pays attention whenever something interesting happens in space. It's cool, but why are they so cool? Rarity? I have NASA stickers for people who answer questions. I am not that good at throwing them, but what else? Anything else?
It's dark and cool.
Yeah, it is so different from any other experience that we've ever had. It's like going to Cedar Point. I'm sure if you go to Cedar Point every single day, the roller coasters are not as exciting, but those roller coasters are very different than riding in a school bus or riding in a car or sitting at your office desk. So it ends up being these unique experiences that maybe we'll only experience a handful of times in our lives. So since we need to talk about the big date, April 8th, notice who is right here at the center. You all. I'm a little jealous on that one because here's Columbus, and OSU is down here. OSU does not hit the path of totality in any way. We get 99.997% coverage, and so we technically could never take our glasses off. But starting around 2 o'clock in the afternoon, the solar eclipse process will begin. That means the moon will start to be moving in front of the sun. Magic starts at about really 3:05, but 3:09 is when you can take off your eclipse glasses and start enjoying things. But as we'll talk a little bit about things, like totality in the sky is only one piece of the entire experience that you're going to be doing. There's stuff on the ground, there's stuff all around you, behavior changes. Totality ends, and then the eclipse will end. But it's at this point here that Ohio is going to get real interesting, because then everybody's going to decide, I want to go home at the same time, and that's where the 2017 eclipse got really interesting. All right, so what is an eclipse? An eclipse, by simple terms, is just the obscuration of light from one celestial body by another passing between you and the observer. You can have eclipsing binaries, or 2 stars orbit each other. We can have the eclipse of the moon and the sun, or the because of where the moon is blocking the sun or the Earth is blocking the moon, and that's the two flavors that we're used to. We can also have eclipsing exoplanets and other things like that. So an eclipse is a simple term, but it's when we get to experience it that we get really interested. So this is a partial lunar eclipse. They happen more regularly. The moon will pass into the shadow of the Earth. Part of it looks like it's been eaten. So if you imagine the moon is a cookie and Cookie Monster is hungry, Cookie Monster is going to eat part of the moon. And then that's what causes what we see. But it's only kind of cool. Sometimes it's just a really light shading and you don't even know that it's happening. But we get these lunar eclipses that are a lot cooler. Sometimes we'll call it a blood moon in the news because it looks blood red. So lunar eclipses are full moons. We'll learn a little bit about where eclipses happen. But you'll get this blood moon because it's passing inside of the Earth's shadow. Now, what do you think the Earth's shadow's color should be? Like we think about it, it's being blocked, you can't see the sun. What color what color should it be? What do you think? Do you know? Gray or dark, black. There should be no light coming through it. But if I'm standing behind the Earth, I'm seeing the atmosphere on both sides of the Earth, the transition between daytime and nighttime. And what happens to the sky when we go from daytime to nighttime? What color is it? Purples and pinks, reds. By the way, here's your sticker. Sorry. So purples and reds. So you get red from sunset. You get reds from sunrise. So what color does the moon become? Red. Because we're having all the light from sunset bend through our atmosphere, and only the red light makes it all the way to the moon. So it's dark, but it ends up being this deep red color. Now, if we go to a solar eclipse, partial eclipse, there's the sun, and the moon has taken a chunk out of it. So again, Cookie Monster likes to eat all the cookies. But then a total solar eclipse is completely different. So now we can't see any of the surface of the sun. The sun's photosphere, or the surface that a lot of us talk about, is completely obscured by the moon. All we can see is the halo around the sun. This is the sun's corona, or the sun's crown. If I were to make an astronomical camera that did this same sort of thing, we'd call it a coronagraph because it does this exact same thing. We block out bright lights from stars and we can see exoplanets around nearby star systems. Or maybe we want to study galaxies and block out light from a black hole that's eating a lot of gas. It's called a coronagraph, but it all comes from the fact that the moon has repeatedly blocked the sun in the past, and it does a really good job of allowing us to see that sun's corona. Now, this is the beginning of the solar wind that steadily streams out through the solar system. But let's learn a little bit about why eclipses happen.
Have you ever wondered what causes eclipses? Every year, the Earth goes around the sun. Every month, the moon goes around the Earth. Every day, the Earth turns on its axis. Hey, slow that down. The moon shines because it reflects the light of the sun. It doesn't produce its own light. Half of the moon is always lit up by the sun. Watch its motion during a month. You see that half the moon is always lit. But during the month, more or less of that lighted side can be seen from Earth, and we call this changing appearance the phases of the moon. Watch again. See how it looks from Earth. The full moon is opposite to the sun, and so it always rises about sunset. Did you ever notice that? At the new moon, the moon is in the direction of the sun. The side of the moon facing us is dark. Also, because the moon rises and sets with the sun, the new moon is only up during daytime and never up at night. However, every year, there are times when the new moon can block all or part of the sun, creating a solar eclipse. At full moon, the moon can pass through the Earth's shadow, causing a lunar eclipse. Notice that everyone on the night side of the Earth can see the lunar eclipse. For that reason, lunar eclipses are not so rare. You might wonder, why isn't there a solar eclipse every new moon? And why isn't there a lunar eclipse every full moon? This is because the moon's orbit is tipped about 5 degrees compared to the Earth's orbit around the sun. We've made the moon bigger so you can see better. If we show Earth and moon to scale, you'll see how small the shadow of the moon is by the time it reaches Earth. So more often than not, the moon's shadow misses Earth when it is new, and Earth's shadow misses the moon when it is full. Roughly twice a year, eclipses are possible. The Earth's orbit around the sun and the moon's orbit around the Earth are not perfect circles. They are slightly oval. There are times when the new moon is farther from Earth and is too small to completely block the sun. During an annular eclipse, there is a ring of fire around the sun. By the way, when the moon is closer to the Earth than average, some call it a supermoon, though 5% bigger isn't exactly super. If a solar eclipse happens when the moon is closer to the Earth, we call it a total eclipse. You can only see amazing phenomena like pink prominences at the edge of the sun and the beautiful solar corona stretching across the sky if you are viewing from the path of totality. If we zoom in to see the moon's shadow, you'll see that it has a dark part and a lighter part. If you are standing in the dark part, you are in the path of totality. The sun is completely covered, and you will see a total eclipse. In the lighter shadow, some part of the sun can always be seen, so you see a partial eclipse. A lot of people think that if you see a 90% eclipse, you've seen most of the show. No way! The sun is so bright that even a sliver of it keeps the sky lit, and you'll miss the most awesome stuff. If you possibly can, go into the path of totality. You'll remember it for the rest of your life. Visit the website www.colorado.edu/FISC or search Fisk Planetarium Eclipse for more information.
So those are the people that I learned all of my planetarium techniques from. I got a lot of experience with them, and they also have a science visualization studio, so they produce some excellent content for planetariums, but also for teaching us about various things. So what they were just describing is that we have a season where our moons can line up. So we have eclipse seasons, and they're about 6 months apart from each other because you have to get the entire moon's orbit to be right when the moon is crossing the Earth-Sun plane when it's on that angle. But for the entire rest of the year, it's off. So eclipses can only happen every 6 months, but we have a chance of getting a lunar eclipse and a solar eclipse, or maybe 2 lunar eclipses during that period of time. So 6 months ago, or not 6 months ago, but 6 months prior to April, in October, we had the annular eclipse that went through the western part of the United States, and then we have our total solar eclipse that's coming through Ohio. Now, to give a visualization of how far away everything is, I have a basketball over here. It's a little bit big for the moon compared to the Earth that I brought, but it's close. You can put about 4 moons across the face of the Earth. But the Earth is on the other side of the room. I'm going to be walking back and forth. Got to get my steps in, right? The Earth is bigger, but we are far away. I can fit 30 Earths between the Earth and the moon. So now you have this moon that's far away, and it just needs to be a few degrees above. It's really easy to miss the Earth. And that shadow is really, really tiny on the entire Earth. So that's why solar eclipses are so hard for us to be able to see. Partial eclipses a lot easier because you're only looking at a piece of the sun that might be missing, but for a total solar eclipse, you're looking at a lot of individual pieces. So this is the path of all the eclipses that happened between 2001 and 2020. We'll just forget that number. But this is everything from the first 20 years of this century. Look at how narrow some of these lines are. Now granted, when we get towards the bottom, you're looking at the curve of the Earth, and so that total solar eclipse is being spread across a lot of Antarctica because you're looking at the edge of the Earth. So you get these wide swaths, but the rest of it is fairly narrow. So even though there were a fair number of eclipses that happened, none of us were remotely close to any of these except for this one. And millions of people got to see this one in 2017. Here's the next 20 years. This is our big one right here. This is our total solar eclipse. This is the annular eclipse coming through this way that happened in the fall. Other than that, the next 20 years, there's not even much that's happening in North America. It's 20 years from now that we'll get another one in the United States. So what should we expect during this time? And we can go back to any of these slides later and we can ask questions about them. But why this event is special? Well, the last annular eclipse that happened in Lima was in 1994. Some of us were alive then. The previous one, I know I was not alive then. And the next one, I might be hard-pressed to be alive then. We'll see. We'll see what medical breakthroughs some of the young people in this room will come up through so that I can see the next annular eclipse that comes through Lima in the state of Ohio. The last total solar eclipse that went through this town was in 1806, before Ohio State was even a twinkle in anybody's eye. At the beginning of this country, the United States at this point was 30 years old. The whole country was 30 years old at that point. That's the last time it happened in Ohio. And we had to wait till the end of this century for the next one. So total eclipses are really rare because we're not flying all over the Earth to go see them. Although there are people that do that. They get really excited after they see the first one. There are people that get married because they met at a total solar eclipse and then they have to have their anniversary at another one. And they will charter cruise ships and airplanes and all sorts of things to go do all these things. But for most of us, we don't have that luxury. And so this is really a once-in-a-lifetime type of event. And the fact that we had two in fairly close succession is really, really awesome. So what should we expect? This is an actual picture from the International Space Station taken of the 2017 eclipse. So we can see sort of the gray area in here. This is where the sun is partially obscured, but it's only in the very, very center that we're getting the full blockage of the sun by the moon. So it's still a really narrow place. But what is it going to look like when we're down here? Well, it's going to start off, hopefully, like a day like this, where it is never going to be clear. But it will be clear enough in Ohio that we'll be able to see the sun, which is a miracle in the spring. But it'll be a beautiful day. We'll see clouds. Everything will be great. And then the moon will start moving across the face of the sun. So this is a picture that was taken with a telescope that is using a solar filter that allows us to see the surface of the sun, and you can start to see that the moon is moving in front of it. And even if it is cloudy, we'll be able to see a lot of this as long as the clouds are not too thick. So even in the fog, we should be okay. As we keep moving it across, if you're looking at it with a pair of glasses, because the sun will be in high activity mode, there might be a lot of sunspots, including some enormous sunspots that might be the size of Jupiter. The planet Jupiter could be blocked out by the sun. So we can see some big dots, even with your own eyeballs, through eclipse glasses. So it might be a really good show, but you can see the moon is starting to block a lot of the sun. When we're looking around outside, nothing looks weird yet. It might start to be cooling off a little bit, but for the most part, your eyes are saying it's the same brightness. There's nothing weird yet. Then we start to get a little bit farther into the eclipse. Not only do they make phenomenal pictures, but at this point, everything is weird. We're now looking at 80 to 90% coverage. The shadows start to change. It is cold outside. Animals start going to sleep. And everything just starts to look different. And then we hit totality. So just like we saw before, this is the sun's corona. This changes based on how active the sun is as well. We're going to talk about solar activity here in just a second. But this is all the sun's particles streaming away from it. It's basically an atmosphere that's flying away, and it passes through, hits our planet, and if it's having eruptions, we can start to see the prominences. These red rings, we might be able to see them because the sun is erupting with huge loops of very hot gas. This is what's called the sun's chromosphere. So right now we're seeing both the corona and the chromosphere, which is different than the actual bright part of the sun, which we call the photosphere. But when we see these eruptions, this is where material can be slung out of the sun, and it can impact the Earth as a coronal mass ejection, and it will create the beautiful northern lights here on the Earth. But these things can change fairly quickly. So when we're out there, if you're lucky enough to be near somebody with a H-alpha telescope that looks at just this color in the universe, you can see these prominence goes up and down, and flares potentially leave the sun and lift away. It's a very dynamic thing that doesn't change on the orders of hours. It's sort of like on the order of like 10 minutes, and the sun could look very different to you. This is a picture I took when I was in Wyoming. This is a full panorama of the sky. This isn't just like one direction. You know, beautiful sunset, take a picture. No, this was sunset in all the directions as you're looking all the way around. And we won't talk about my photography skills at that point. But it really was like you have this bright band on the horizon, and the rest of the sky is dark. You see this sun as like the eye of Sauron staring at you if you like Lord of the Rings. And then all of a sudden you'll see planets and bright stars poking through. The difference between the 2017 eclipse and this one is the moon is closer to the Earth. It's closer to the Earth. It blocks out more sunlight because it's bigger. It blocks out more sunlight. We can see darker things in the sky. It's going to last longer. So this next eclipse is even more special because it's going to be almost twice the length of the last one. And it's going to allow us to see more things in the sky. So why are eclipses good for scientists? Like, it's a really cool thing to see, and most of my department will not be in the state of Ohio, or at least definitely we're not in Columbus. People ask us, like, were you gonna do anything on campus? And we're like, no, we're not missing this. So we're all driving to various places with our friends and family to go see. But there are scientists who chase eclipses because they can learn things. And so let's talk a little bit about that science. So one of these things that you can do if you wanna work for NASA and be a pilot, you could be special enough to get in a high-speed aircraft. They attach a bunch of ultraviolet cameras onto the back of it, and you're gonna go fly along that eclipse path. Go as fast as you possibly can to stay in there for the longest time possible to image the sun. Because if you're imaging the sun and watching that corona change over time, you might see eruptions and how they ripple through the corona. We, as scientists, are trying to figure out how the sun's surface and its outer layers of its atmosphere interact with each other and then heat up as they enter the solar corona and then expand out through the solar system. So understanding how those waves move through this material, how quickly they move through this material, tells us about what might be propelling them and maybe ways about how these things are actually accelerated. This right here is a type of data that Ohio State has taken. The Ohio State Earth Sciences Department looks at this same sort of phenomenon. What we're looking at here, you can see where the shadow is, but we can also see these rings behind it. What this is looking at the ionosphere. So this is the part of the upper part of our atmosphere. For those of you that remember AM radio, it's the part of the atmosphere that's responsible for bouncing those AM signals around the Earth so we can hear stations that are on the other side of the globe. If you're too young, I'm sorry. But it's the part of our atmosphere that gets ionized, so electrons get knocked off of atoms by ultraviolet light, and then when the sun passes over the top of them, there's no ultraviolet light, so they recombine. So this is the way that we can study how the change from daytime to nighttime and then back again can happen really rapidly, and we can understand the phenomena that are happening in our very high atmosphere. But we can watch this occur. If I can make this do it again, let's see if we can do it. There we go. And we can see all the structures that come out of that. So the atmosphere is a very dynamic place, even though all we're doing is changing the light that is shining on it. This one's kind of important. It's a little bit easier to understand. This is literally the total amount of energy that is hitting the ground. Now, why might this be important nowadays? This is worth a sticker. Where do people get energy from nowadays? A lot more sources than what we used to. Say it out loud. That's the right answer. The sun. We can get energy from the sun using solar power. So if you're trying to plan to keep an entire nation's network, the power grid online, you need to know where it's hitting the ground. Because we have to turn on other generators. You have to do a lot of things in order to make this happen. If you're controlling air traffic, most people get terrified when you drive into a wall of darkness. So a lot of the FAA is moving flights around the eclipse path, except for those that are going straight into it because they want to be there. But they don't want people to panic on an airplane because the end is happening and it gets dark all of a sudden, and they don't know why. So understanding how the eclipse moves, how it affects the ground, this is going to affect wind currents and all sorts of things. And so being able to model this out helps us understand how we can keep moving forward with different types of energy sources. And I show this because we were talking about the ionosphere, so we're way up here. But we can see different layers of the atmosphere can potentially glow when they get excited. What do we call that? Anybody know? We can see it here in Ohio. Yeah. The northern lights, the aurora borealis. And I do owe you your sticker. But the aurora borealis happens when those charged particles from the sun slam into the earth and excite the atmosphere just like we would a fluorescent light. And that happens most when the solar activity cycle is peaking. This is our current sunspot data. Number of sunspots increases when we have high solar activity, which means number of eruptions increases. The sun's magnetic field gets really excitable. It's really fun. But we're heading towards solar maximum. This is really cool for a lot of reasons, because in the past 6 months, we have had a number of events that have caused the northern lights to be visible over the state of Ohio. Every single one of those nights was cloudy. But if they could see the pictures in Arkansas, I guarantee you we could have seen it here if it wasn't raining. But these are the types of things that we can look out for because we will be able to see all of this. The difference between solar minimum over here and solar maximum when we're looking at the sun's corona. You can see that there's a lot more structure on this side. So I don't know what to expect when we're going to be looking at the sun in April, but it should be exciting and different. And if there's an enormous solar eruption that hits the Earth at the right time, there's no reason why other things in the sky could be happening at the same time too. One of those things can also be one of the comets that's passing close to the sun. I have not looked into it to know enough about exactly where it is, but it will be visible in the sky if it happens to flare in the right way. And we'll be able to see that in the sky as well. So you'll see the eclipse, the corona, all the other cool things that are happening, a comet, stars, and it'll be really awesome. Yes?
So is the one on the left what here in Ohio we would have seen in 2017?
More so, yes. Where it's basically there's limited structure to it, but then when it gets excited, you can see that it streams out in much more collimated ways. But yeah, in 2017, we were near solar minimum, so it's kind of boring. But this is a H-alpha telescope image. This is from Lunt Systems. They build amazing solar telescopes. I just happen to like them because I've gotten to see a lot of stuff in them. But we're looking at this edge when we're seeing that prominences and that chromosphere. We're seeing the stuff that's lifting off the sun. It's still very hot gas. But this is the stuff we see, and then while we're sitting there waiting for stuff to happen, these are the types of things that we can see when we're looking at the sun itself. So there's a lot to see and enjoy as we're leading up to the event. And then for those of you that have not seen it, here's your aurora. Now, my next big thing that I like to talk about, and it's because I don't want anybody to get hurt, is safety. So with eclipse safety, what should you never do? Ever look at the sun. You should never look at the sun. If you can see any part of the sun's surface, you should have protection over your eyeballs. Are sunglasses good enough? Never. There are no sunglasses that are good enough to protect your eyes. In fact, most welders' glass is not good enough to protect your eyes from staring at the sun. There are specific kinds of it that are okay, but most do not. So this is just stuff off of the AAS or NASA's webpage. They're nearly identical to each other. But here's the standard up at the top. I just show it because there's a lot of stuff in here. But you want to have approved glasses, hopefully made in the United States. Two big suppliers in the United States are American Paper Optics and Rainbow Symphony. Both of them have film that meets these standards. If they are shiny on the front, then they meet these standards. If they are dark and they are over 2 years old, don't use them, because those are the old dye-based glasses. Now, most people don't produce those anymore, but you need to be careful and use the shiny ones, and the shiny ones will last for a long time, because that metal film rejects a lot of the light that we're looking for. But you want to be careful, and whenever we're looking at the sun, we put our glasses on, and then we look up and find the sun. It's the only thing in the sky. It's really easy to find, and you'll be able to feel the heat on your face. So you can kind of turn towards the warmth, and then the sun will be there. But you want to put your protection on, and then go looking for the sun. And then if you're in the path of totality, you don't want to look until it gets dark. That's the key piece. If you can see that edge, it's too bright. Now, there's a chance that you might accidentally catch the sun in your eye. That's not going to hurt you. But the reason why we want to be extra careful on the day of totality is that we're going to be catching the sun in our eyes an awful lot, because we're going to keep wanting to look at it. For 2 whole hours, we're going to be trying to look up at the sun. So it's going to be a lot different than I caught it once while I was driving home. This is going to be like we're going to spend some time looking at it. So you want to be careful with all of these. Now, if you are outside the path of totality, if you live in Columbus like me, it's never going to be safe. We are never going to have enough of the sun covered to actually enjoy taking off our eclipse glasses. Now, even my parents' dogs, totally prepared. So Kimber right here has her eclipse glasses on, and so does Lily. So they are wildly prepared. This is our last eclipse. Now, this was while it was still, the sun was up and we could still, everything was bright, because by the time it got dark, they wanted to go to sleep. Like everything else that's happening around us. Now, I think, was it last week? Was your last talk? 2 weeks ago? I just heard about this earlier this week, but I think it's so cool, and I want to watch the video. But like animals change, right? Your nocturnal animals are waking up. Your daytime animals are going to sleep. When you start to look at the shadows on the ground, it's actually another way that we can observe the eclipse is by looking at pinhole cameras. Leaves create these little tiny pinholes. And so we're used to having small images of the sun, little spheres or little circles on the ground. They overlap each other. Everything just looks fuzzy, right? And so we're used to seeing those fuzzy shadows on the ground. But when we start to see them with a crescent sun, those are not circles anymore. Those are little crescents. And they're stacked all over each other. And so all of a sudden the shadows become sharp and weird. But that means we can take that effect and use just a colander. This is just a spaghetti colander. You line it up and you can see a bunch of shadows on the ground and you can observe the sun through a bunch of pinhole cameras. Same with a slotted spoon, your fingers. You can take a big sheet of cardboard and poke a hole in it, and you can observe the sun with a group very, very safely, so you don't have to have the glasses. This is off of a telescope that you can then pipe the image onto a screen. Or here's that other example of those weird shadows on the ground. Now, in addition to the weird shadows, right around 90% is where the sky starts to feel like you're having a seance. Most of you are old enough to know that switch from incandescent bulbs to the first generations of CFLs was a little weird. The light in your house was kind of this dim kind of haze, and you're like, whoa, that's what it's going to feel like, is something feels very wrong, but it's still going to be bright enough you can see everything, but you know by your eyes that something has changed. And then a few minutes before the eclipse, you'll be playing up, you're going to be looking down, and the reason I say you're going to be looking down is right before everything happens, you start to see shadow bands on the ground. It's basically the interaction of the shadows and the edge of the moon passing through the Earth's atmosphere, and it looks like snakes swimming on the ground. It's kind of crazy, but everything will look really weird. But like when I say you have to be looking up, down, all around you, this is an experience that you kind of have to live the entire event. It's not just one thing. And we can pull up a video of that here in a minute. I didn't have it in there. But here's the details. And if you want that map, I'll put this link up. And then if you have any questions, you can email me at solareclipse@osu.edu. But I'll leave this up and take any questions if there are any. Yes?
I was wondering how fast that aircraft goes, or how fast in relation to the eclipse, because does the aircraft keep up with the eclipse, or does it fall behind it?
I don't think NASA pushes it hard enough to actually keep up with the eclipse. I think they fly multiple aircraft over multiple areas, I think.
The eclipse is moving over 1,000 miles per hour.
Yes, yes. And yes, we have airplanes that can do that. It's just whether or not it's worth it when you can have different experiments, they'll launch in different parts, and then they can keep up with them for, get 10, 20 minutes out of it as it moves across. Yes?
So how do we find out if the aurora borealis?
So the aurora borealis. I will show you my favorite page. I think I can bring this up here while we're doing things. Is I like to go to the University of Alaska because they specialize in this stuff. I think it's GI. It's the Alaska Geophysical Institute. And then you can find somewhere in here their auroral forecast. And so this is a great place. I always use it because you can come in here, and when you come down a little bit, you'll see, okay, so here's a picture that doesn't represent Ohio, but you can look at this graph right here. These are days where it's peaking. These are really good numbers, especially to see them in Ohio. But then we can come up here and we can click on North America. And North America will update the picture of what we can see. So here is where the auroral band can be. Doesn't mean that it's going to be active or very visible, but this is where it should be. And this is the southernmost extent that you can see it. Here is Lake Erie, and here's where you guys are right at the edge for tonight. But if we click forward just a little bit, let's see if that gets better or worse. There we go. I think that gets worse, yeah. But basically, when we get a really exciting day, you will see these things move down. And basically, we will be able to see, like, this line will sometimes be over Lake Erie. And so the bottom of this line will intersect some of our lower states. And so when it intersects with Texas and Arkansas, you know dang well that if it's clear, we're going to be seeing glowing. And I've missed it every single time. I was like, I'm going to stay up late. I'm going to watch it. In 2004, completely fell asleep after playing video games, and I was in Albuquerque, New Mexico, and they had a tremendous number of phone calls to 911 saying the Sandias, the mountains right north of us, were on fire because they were burning. All the red glow, but nope, it was the red glow from the sky. And then here it happened, I think 2 years ago. One of my students stayed up late, and they saw it, and I was like, oh, I guess I was asleep. So there's a lot of neat things that are happening, and sure, a lot of us are not going to stay up all night to catch the one chance, and so it might be good to take a trip to go see some of these things. But these are things that we can experience down here too. Yes?
2017 was a solar eclipse.
Yes.
Roughly 7 years between that one and this one, and I saw on your future projection 2093 and 2099, roughly 6 years in between. Is there any correlation?
So it is related to the where the moon is, and so you have the moon, and part of the reason that it doesn't happen always in October and in April is that the moon's orbit is slowly precessing as it moves around, and so that's going to slowly change. The last one that we had was in August, and so you have August to October. It's moved several months in that sense, so it's moving around because the whole orbit precesses. The reason that we have easily predictable lunar eclipses is because of the moon's cycles and how it's moving around. So I would assume that there is some pattern that relates back to where that is. However, the gap that we're looking at, that thin band that we see across the Earth's surface where the total solar eclipse path is, that's so narrow that it's hard to read into that as like that's an actual pattern. I think that's more luck. Other things can pass in front of the sun. Venus can do that. None of us will be alive when Venus happens to do that again. The last time we do that in 300 years or so was 2012. So sometime in the future, our kids and grandkids and great-grandkids and their descendants will be able to see Venus pass in front of the sun. And that does happen twice in 7 years, and then it's done again for another 300 some years or something. Don't remember the exact number. Yeah, Mercury does it every few years, I think, where we line up and it's easy to see. But Mercury is also hard to see because it's just a tiny little dot. Other questions? So as part of the state level planning, some of us talked about this at the beginning, I have been involved since about 2020 in planning for this eclipse. So the state has been trying to work out, okay, so what do we need to know before we all get into this situation in April? Because you have a lot of people coming in to the state. So where are they going to stay? Where are they going to gas up? Where are we going to park them? How are they going to get home? Because they're all going to leave at the same time. So how do we keep them here for an extra day so they go home slowly rather than all at once? How do we make sure that there's enough food in this state? In some of the plain states, restaurants, like, they had thousands of people, so they were just feeding people like crazy, ran out of food, went to the supermarket, bought everything, and there's nothing in the supermarket now. So those are things that, like, if it were me, over the next few months, I would not wait until right beforehand, nor would I run out and buy everything. But, like, planning ahead for a few extra meals, the retailers in Ohio have been alerted to what is going on. They've been through this once. They know how to move product to the places that they need to be. We've been trying to work with small communities to understand that, yes, you can only process 500 people's worth of water and waste every week, and you're going to have 10,000 people in your park. Good luck with that. So, like, being prepared for those things in advance and helping them think ahead when it's not something that we're used to. I don't even know what to expect or what to plan for. But if there's a big emergency, having ambulances and helicopters in the right places to bring people back and get all those things organized is a big deal. And so we've been working on that for about 4 years, and Ohio really has set the example for the eastern part of the United States on that front. So it's been really, really cool, and that's how I know how many porta potties there are in this state. And I know a lot of other details that I really don't want to know about this state because of it, but it's pretty cool. And I'm not going to tell you to skip school, but skip school. Whether or not the school districts are open, you should just enjoy this. This is a once-in-a-lifetime type of thing. The next one that happens in the United States 20 years from now, I'm going to be leaving my career, hopefully, and retiring. We'll see. But it'll be someone else's job to do all this stuff. So it's going to be a long time before the next one that we all get to enjoy together without getting on an airplane. So enjoy it while we have it. Yes?
Do you remember what else is going to be in the sky during the eclipse?
Orion's going to be up, but that's not an event. It's just, that's an easy constellation for people to find.
Right. It's the brightest constellation.
Yeah.
But what about the planets? You know which planets?
I do not know which planets are going to be up.
I think the 4 brightest ones.
So that's going to be Venus, Jupiter, Saturn, and Mars?
And I think the 2 brightest ones are split, one on each side of the sun.
Nice. So there's going to be stuff to see. Even if it's slightly cloudy, there's going to be stuff that'll poke through all of that we'll be able to see. That'll be exciting. Yes?
At the last lecture, the gal told us about a NASA citizen scientist for sound study. Do you know of any other citizen scientist things that are coming up with this?
I don't know off the top of my head, but I'm more than happy to help you look and find some resources and get them posted.
I know of one. I'm also a ham radio operator. And there is
Yeah.
a citizen science project for the ionosphere bouncing the radio signal so they can study that during the eclipse.
So what happens is as you're recombining, you're creating this layer of electrical conductivity in the atmosphere that makes it really easy for radio signals to hit that layer and then bounce back down to the Earth. And so that allows ham radio operators, instead of doing line of sight, to bounce and then talk significantly farther than they normally would. Yes?
You mentioned that, or hinted that some of your coworkers are going to see the eclipse in other places.
Yes.
I'm curious what, like, the ideal things to see are.
So-
Make sure you see the
So this place has been recommended by the John Glenn NASA Center, mostly because they're in this place. But Lake Erie is supposed to be really cold in the spring and does push back the cloud deck. So they're expecting it to be relatively clear. I'm traveling to Texas along with several other people in my department, but I'm going there primarily because it's halfway. It's the most equidistant point between me and my parents, so we can all kind of meet down there and experience it together. I think a lot of people are just going to where they have family along the path because it intersects with a lot of major cities. Dallas, San Antonio, Austin is really, really close to it. Plus you have St. Louis and then, Lima, Cleveland, all the way up through the stuff in New York. So there's a lot of major cities. that can house a lot of people. So a lot of people are just trying to go where they know people.
And the state of Ohio is pushing people up towards Cleveland, Avon Lake. If you go to the state of Ohio's Eclipse website, they incorrectly tell you that the longest eclipse time is up at Avon Lake. When, if you study the maps,
We won't tell them all of the details. Just kidding. No, but it's close, and you're right. So it's longest eclipse timing because it's in the very center of the band, not necessarily the longest eclipse time for the entire state.
right,
But Avon Lake happens to be right on that center line. So the closer you are towards the center, which is why Lima's pretty dang good in here in the middle, is that eclipse is going to last longer. If you're near the edges, you're going to get the edge of the moon that is smaller, and so it's going to pass across the sun a lot quicker. So it's going to not last quite as long, and it won't be as dark.
there's about a minute difference between the edge and the center
Yep.
for the amount of time in totality.
And that's what each of these small lines represent. So like this is the 1 minute line, 2 minute line, and I think anything is in here is 3. I think. It's on the very edge of the map. They make it very hard to read.
We're just short of 4 minutes.
Sounds like everybody's ready for some cookies. All right, well, I guess I'll hand it back over to you. And then if you have any more questions, I'm more than happy to keep answering questions for whatever.
Thank you, Dr. Schlingman. This was so incredibly interesting, and I know that it increased my fascination, and I'm sure it increased yours as well. So thank you all for attending this evening. Our next lecture will be at 7 p.m. on Thursday, February 15th, where we'll be in the Martha W. Farmer Theater for the Performing Arts at Reed Hall with one of NASA's senior aerospace engineers. And among other things, Craig Williams will explain the physics and geometry of the eclipse and some safe watching sources of information. The final of our Eclipse Science Series events occurs on March 21st in Science 100. Meteorologist Dustin Norman of the National Weather Service will talk about how an eclipse changes the world around us, however briefly, including effects of the weather. He will also dive into some of the other unusual weather phenomena that happen in the Midwest, which we love talking about all the time, so that's always a good thing. Thank you so much for joining us tonight, and information can be found on the flyers that are in the back alongside the cookies and water, and thank you so much for coming.